So this is the very last section in our word recognition set of topics. And it's sort of an interesting section, but it doesn't quite fit with a lot of the other stuff we've talked about, so I've got it kind of its own separate little video. Is lexical ambiguity. So what happens, we've talked about how people recognize words just like perceptually, we've talked about priming and context and all these things. So let's talk about like what happens when a word is ambiguous and we're not sure which one it is. So this really gets into the idea of I can actually recognize the letters on the page, but what happens when there's a couple of options to pick from? A couple types of ambiguity. So homophones, so words that sound the same but have different meanings. So bank and bank, so bank of a river and bank of money. I know most people don't think about rivers as river banks, but they are both valid. So pen and then the different spelling, but it sounds the same. So how do we process those if we're hearing? And then some that are called heterographic homophones. So words with different spellings that sound the same. So if you're listening to this, night and night, soul and soul. So how do we process those? Homographs are words that look the same but are pronounced differently. So I can get led, like Led Zeppelin, only not spelled the same, or I can be led to the store, so I can lead someone, like a horse. So it just kind of depends too. Also, read and read. Those read in general, color versus I have been reading, are also some homophones. So homographs are words that look the same but are pronounced differently. And polysemous words are words with multiple meanings. So letter can be a single letter, can be a letter, written letter. And so how do we deal with the fact that these things sometimes are pronounced differently and sometimes they have different meanings? So polysemous words, they sometimes have multiple meanings. So the words are completely unrelated, but sometimes they also have multiple senses. So a twist could mean to turn something, it could mean to sprain an ankle, it could be you twisted my words. So like, how do we discern which meaning of the word to use? So it could be that the words sound the same and they're totally different meanings, or it is the same word, it just has different dictionary definitions. So a couple of models for this, because there's models for everything, is the context guided, so context clues, single reading, lexical access model. Ugh, such a mouthful, and it doesn't abbreviate well. But context is the most important part of this. So as you're reading along, and we'll talk a lot about reading later, so this is just sort of in this section because it's a part of word recognition that's interesting. Context restricts what's relevant. So this is very similar in idea to that demon shouting logogen model, or that expectancy generation that we talked about with lexical decision tasks and naming models. So the janitor cleaned the floor with the mop. So as you're going along, you are generating what you would expect to hear. So context is ruling out other forms of the word or other forms of meaning for you. Then within that, there's also ordered access. So this is frequency, but now frequency of meaning. So all of the different senses of the word are activated, but in frequency order. A pen is a writing utensil versus a pig pen, which is an animal holder. And so pen, the writing utensil, is much more frequent of an interpretation, so that one gets accessed first. And then as context gets added into that, context will rule out some of the options. A multiple access model instead says that everything is activated at once, just all of them willy-nilly instead of frequency activated, and then just the appropriate one is chosen by context. So the ordered access model is that they're activated one at a time based on frequency and then checked against context. This was like, whatever, they're all activated and the best one gets picked. So here's some fun experiments that people did to try to figure this out. So the participants were shown things like, after taking a right turn at the intersection I, blah, blah, blah. After taking a left turn at the intersection I, blah, blah, blah. So which one do you think takes people longer to create a sentence from, right? And so what's happening is right here has two interpretations. I took the correct turn, or I literally took a right turn. And so people take a little bit longer when it comes to the first sentence because they are trying to process out if I meant I took the correct turn or if I took a literal right turn. So this is actually right when I'm giving directions to people and they say right turn, I always say correct, because then it's not confusing if it's actually right, you're right, and they go, really, right? And then you play that who's on first game. But after taking the left turn, there's no ambiguity there. Then experiment 2, what they tried was the farmer put his straw beside the machine, and the farmer put his hay beside the machine, and straw is more confusing because it has multiple meanings, or longer recognition times. Hay doesn't really have multiple meanings. So straw, the more common interpretation of straw is a drinking straw. So in a dichotic listening task, okay, so dichotic listening task is where they're playing two different things, one in each ear. So we have attended ear, the one you're focusing on, and the way they make you focus on it is you're repeating it aloud, like blah, blah, blah. So I'm hearing John went to the store and blah, blah, blah in this ear, and I'm saying it aloud. And then an unattended ear where they're playing another person speaking, and I'm supposed to be ignoring it. So in the attended ear, we say, the spy put out the torch as a signal to attack. In the unattended ear, we heard, the spy extinguished this torch in the window, or the spy displayed the torch in the window. Okay? So put out the torch could literally mean put it out, like de-lit it, so to speak, or it could mean put it out like I set it out so people could see it. So what happened is that people are trying to, sorry, I thought I had the results on the next slide, but I don't. People are trying to discern which meaning is correct. And so that unattended ear, even though they weren't supposed to be listening to it, biased their answer towards what they thought it meant. So if you heard extinguish, people would say, oh, there's no more lights. If you heard displayed, they would say, the light became brighter or something. So they would come up with explanation that matched that unattended ear. And so it wasn't, this experiment really supports sort of priming in context, because it's not the most common or most frequent response, because to put something out, most frequently people tend to think of as extinguish. If you put out a fire, that sort of thing. Okay. So people are slow to find ambiguous words when they match the most frequent context. So here's an example. The accountant filled his pen with ink. And so it's difficult to know that the word pen in that sentence is the ambiguous word, because you just don't think about pens like animal pens unless you are a farmer. So the farmer put the sheep in the pen. Both times it's difficult to figure out which word is ambiguous. But in general, the first time is the most difficult. The second time you go, oh yeah, maybe you meant like writing pen. But in this one, people can't even think of the other alternative meanings. You have to usually tell them. And then priming also shows us that selective access is occurring. So selective access is when we're picking the most frequent option first and then checking it against context. And so if you show people this order of words, save, bank, money, what you'll get is that with save, all the other context options drop out for bank. If I show you river first, the next word for bank, it makes sense. Riverbank, okay, fishing and all these other things. So you have a really slow time with money, because normally bank primes the money, but in this case I've been biased towards riverbank, so I'm thinking fish, right? And then if you show people day, bank, money, bank does prime money because day and bank are unrelated. So if I give you context-based ones, it changes the interpretation of money. This one it makes money faster, this one it makes money slower, this one it has no effect on the word money in the sense that bank primes money all by itself. So here's I'll just take one last example. So rumor has it for years that government building had been plagued with problems. The man was not surprised when he found several bugs in the corner of the room. Okay. So what happens is they read this particular thing, and then they got a lexical decision task after the word bugs or the word corner. And so after the word bugs, we get priming for both ant and spy. So bugs prime us towards ant and towards spy, given that this is a government building, so it might be a spy. That both options for the word bugs were activated at once, instead of only one option. So this sort of gets into that multiple access model. It appears that both of them were available only after the word bugs. Because once we get to the word corner, so in the corner of the room, if you imagine maybe, like, I guess a spy hiding behind a curtain, like in those old TV shows, but once you hit the word corner, you only get priming for ant. Okay? And so it appears with these studies and a couple of others that the multiple meanings one is true in the sense that right away we get all the different options activated, but a couple words later they've all dropped off, and so only the most relevant one is activated. And so multiple meanings appear to get activated quickly, but that controlled context process eliminates the rest of them kind of quickly. So the reason we might not see multiple meanings being accessed in some of these other experiments is simply because they've gone away, the access has gone away so fast that we missed it. Right? And so in summary, when we hit an ambiguous word, we'll activate all the meanings of those words. So that's been fairly well supported now. However, context is so fast at rejecting the non-related meanings, 200 milliseconds or less, that often we'll miss the fact that we've activated all those different meanings. If the meaning is less frequent, and that's the right one, it takes much longer to access because it just needs more activation, because frequency is kind of like tampering it down. And that sort of implies that our semantic understanding, our meaning understanding of sentences is word by word. And so after the word bug, we can see that people have multiple meanings accessed, but a couple words later, it's clear that one of them the other meanings have been dropped off. Some more recent models of this topic include a selective access model. And so these are kind of responses to the multiple meanings and this sort of way that this happens, is that all of that prior information up to this point constrains so that, yes, multiple meanings are accessed at once, but only the ones that make sense. So if I have a word that has 10 meanings, but context up to this point has ruled out 4 of them, I will only get the last 6 activated at once. And so if leading up to the ambiguous word, all of the other contexts are ruled out, you'll only see the one come up. And so that's one reason why we may have missed that things happen in the multiple access model is probably a little bit more correct, is because that's multiple access, but only based on context up to that point. Reordered access model is the more appropriate meaning is increased, so there's more activation for it. So instead of selected, the idea is instead, yes, they're still all activated, but they're structured based on context. So the frequency of those contexts will reorder which one is accessed first, instead of just general word frequency. Okay. The last little model I think we're getting to here is the autonomous access model. So the automatic access model is that context has no effect, which seems a little silly given what we've read already, but the integration of the word with the word we're trying to process, that ambiguous word with the previous word meaning, basically just totally kills activation for everything else. So the fact that context isn't changing the activation of this word, but it's changing the properties of what could be activated. And I don't know, So here's an experiment. Having been examined by the king, the page was soon marched off to bed. Okay. And so that is kind of a positive match. Having been hurt by the bee sting, the page was soon marched off to bed. So page there is a lower frequency in our understanding of that sentence. We would normally activate book page first, but king here has ruled that one out. Just as Henrietta feared, the page was soon marched off to bed. So there's no biasing context there. Okay. And so it appears that reordered access is the most supported model in this idea. Is in this first one, the meaning of this word, the way we're supposed to interpret it as person, has been increased because of king. That word is tied to that one. Having been hurt by the bee sting, the page was soon marched off to bed. That's sort of a negative context, so it actually hurts us in our interpretation here because context has led us in a different direction. And then here, there's no context to be had. And so the activation's somewhere in the middle. Okay. So, kind of a summary of this section, this is the part that's important, is that the access of the meanings of the words after word recognition on just a purely physical level depends on frequency of meaning and the extent of how well context has disambiguated what's going on. So context and meaning, word frequency, frequency of meaning, not the word itself, interact to help us de-ambiguate sentences.